Okay, we are going to talk about solving exponential equations and solving logarithmic equations. So this is section 4.4. Sorry, just a second. Let me move this where you can see it a little bit better. There we go. Okay, so there are two different types of equations. There's exponential equations and there's logarithmic equations. And then within those two different types, there's two different types of those. So there basically is four types of equations we're going to go over. Okay, so we're going to start off with the exponential equations. Okay, so again, two different types of equations. The first kind of equation, or the first way to solve it, is to essentially, the idea is to make the bases the same. And again, this is kind of a lot of information at the beginning since you haven't even seen a problem, but usually we turn it into a smaller base. Okay, so lots of times people try to make something into a bigger base. It actually we're turning things into a smaller base. So for example, if I have the problem 2 to the 3x minus 8 equals 16. Okay, so look at your bases here. On the left-hand side, I have the base of 2. On the right-hand side, I have a base of 16. What's the exponent for the 16? Technically a 1, right? So 16 is a base. The idea here is if I can turn these both into the same base on bottom, then I can just set the exponents equal to each other. Because if I had like 5 to some power equals 5 to some power, the 5s don't even matter anymore. I have a power equals power, right? So the question is, do I turn 2 into a 16 or do I turn 16 into a 2? Okay, this is the idea. We always want to try to make it a smaller base. Okay, so what you want to do here is I want to turn the 16 into a smaller base of 2. Can I rewrite 16 as 2 to some power? Yeah, 2 to what power is 16? Yeah, 2 to the 4th power is 16. So since 16 is the exact same thing as 2 to the 4th power, I can just rewrite this problem as 2 to the 3x minus 8 equals 2 to the 4th power. I did not change a single thing in here. This is the exact same problem. I just changed the way it looked because 2 to the 4th and 16 are the exact same thing. But now that your bases are the same, since the 2 and the 2 are the same, we can just basically ignore them and set the exponents equal to each other. So 3x minus 8 equals 4. And then we're going to solve for x. How do you solve for x here? Add 8, and I get 3x equals 12, divide by 3, and I get x equals 4. And that is your answer. Okay, let's do a few more of these. If I have the problem 27 to the x plus 3 power equals 9 to the x minus 1 power. Yeah, in this case, I can't really rewrite 27 as a power of 9 because like 9 squared is 81 and 9 there's not really a way to write 27 as 9 to some power. I can't go the other way either. I can't write 9 as 27 to some power, but these are both powers of 3, right? 27 is the same thing as 3 to the third power. And 9 is the same thing as 3 squared. So I can rewrite both of these. So instead of 27, I'm going to write this as 3 to the third power, and that's raised to the x plus 3 power. And 9, I'm going to write that as 3 squared, and that's raised to the x minus 1 power. Okay, from here, if I have a power raised to a power, what do I do with it? You're going to multiply it, right? So I need to distribute the 3. Same thing over here with the 2 and the x minus 1. So this is the same thing as 3 to the 3x plus 9 power equals 3 to the 2x minus 2 power. And then you can just get rid of your bases since they're exactly the same. And I have 3x plus 9 equals 2x minus 2. And solve for x. So I'm going to move the 2x over, subtract 2x from both sides, and I get x plus 9 equals negative 2. Subtract 9, and I get x equals negative 11. Questions about that? Okay, try this one on your own. 5 to the 3x minus 6 power equals 125. Okay, so for that one, you don't want to write 5 as a power of 125. You want to take the 125 and rewrite it as a power of 5. So you're always going to a smaller power. So like usually your powers are going to be 2, 3, 4, 5. Okay, so 125, we can rewrite it as 5 to the third power. So this becomes 5 to the 3x minus 6 equals 5 to the third power. And then we can just ignore the 5s at that point, and I get 3x minus 6 equals 3. To solve for x, add 6, and I get 3x equals 9. So x equals 3. Questions about that? Okay, try one more on your own. What about if I had 8 to the x plus 2 power equals 4 to the x minus 3 power? Okay, for this one, what base are you turning these both into? Okay, so if I tried to do 4, can you write 4 as some power to get 8? Like 4 squared is 16. Okay, so we can't write them both as a power of 4, but I can write them both as a power of 2, right? Because 2 squared is 4 and 2 to the third power is 8. So this is going to be 2 to the third power raised to the x plus 2 and 2 to the second power raised to the x minus 3. And then distribute. So I get 2 to the 3x plus 6 equals 2 to the 2x minus 6. And then you can just ignore the bases at that point, set the exponents equal to each other. So I get 3x plus 6 equals 2x minus 6. I'm going to subtract 2x from both sides. And I get x plus 6 equals negative 6. Subtract 6. And I get negative 12 as my answer. Questions about that? Okay, let's do one more of those. This one's a little bit trickier. What about if I had 5 to the 2 minus x equals 1 over 125? Close. There you go. So the idea here is you're always trying to get a base of 2, 3, 4, 5. Like I can't stress that enough. Okay. So here we already have a base of 5. So I need to figure out 5 to what power equals 1 over 125. How do I get a whole number into a fraction? What kind of exponent do I have to raise it to? A negative exponent. And how do I get 5 to turn into 125? It's to the third power. So this would be 5 to the negative third power. Okay, so then I get 5 to the 2 minus x equals 5 to the negative third power. Your bases are the same. So I'm left with 2 minus x equals negative 3. To solve for x, I'm going to subtract 2. I get negative x equals negative 5. Then if I divide by negative 1, I get x equals positive 5. Questions about that? Okay, so that's the first type of exponential problem. Exponential equations always have an x or a variable in the exponent. So the first type of situation is where you can make your bases equal to each other. The second type of problem is what if I couldn't make the bases equal to each other? For example, so this is, I'm gonna leave a space up here. For example, the problem like this, 4 to the x power equals 15. Okay, can you make 4 and 15 into some base that's the same? No, I could write 4 as 2 squared, right? Can you write 15 as 2 to some power? No. Not easily, right? It's a decimal and it's ugly and it's awful. So this is the problem where you cannot make the bases the same. So if you cannot make, oh no, my pen ran out. You cannot make the bases the same, then we are going to use the inverse to solve it because inverses undo things, okay? What is the inverse of an exponential function? A logarithm, okay? So we are going to put it into logarithmic form and that's going to fix our problem, okay? So we are going to change forms. You can't make the bases the same, then you need to change forms. So let's change forms here. This is an exponential form. Let's put it into log form. To put this into log form, it is log base. What's your base here? 4. Log base answer of 15 equals my exponent. So I just need to figure out log base 4 of 15. How can I figure out log base 4 of 15? Yeah, you can put it in the calculator by doing the change of base formula. Change of base formula is log of the big number divided by log of the little number. You can do natural log or log base 10. It's up to you. Okay, so log base, I'm going to do log base 10. So log base 10 of 15 divided by log of 4. If I type that in my calculator, that gives me my answer. Okay, so log of 15 divided by log of 4. Make sure you close parentheses when you're typing this in. And you get 1.953. And that's your answer. Questions about that? Okay, let's do a few of those now. So this is number 6. Oh, pin number, I forgot. Number 6, if I had the problem 10 to the x power equals 120,000. Okay, I cannot write 120,000 as a power of 10, not easily. So I'm going to change forms here. To change forms, we're going to do log, what's the base? 10, log base 10 of 120,000 equals x. And that's pretty nice because can't I just type that on my calculator now? Because it's base 10. So you just find the log of 120,000. And I got 5.079. Questions about that? Okay, let's do a few more of those. What about if I have the problem 2 to the x minus 5 equals 8? Yeah, before I can change forms, to change forms, it has to be some base to some exponent equals some number. Okay, so I need to move this 5 over. So I'm going to add 5 to both sides first. And I get 2 to the x power equals 13. So then from there, now I can change forms. Log, what's my base of my log? Log base 2 of 13 equals x. Okay, that's a number. I can use my calculator to get that number. I have to do the change the base formula. Change the base formula is log. This time I'm going to do natural log just to change it up a little bit. So natural log of the big number, 13, divided by natural log of the little number. When I say big number, little number, I don't mean like the greatest number and the least number. I mean like size big. Okay, so like small would be the base and big would be the thing you're taking the log of, just to clarify. Okay, so natural log of 13 divided by natural log of 2. I'm doing natural log this time just to show that you can do it that way also. Natural log of 13 divided by natural log of 2. Regardless of if you did natural logs or common logs, you should have got 3.7. Questions about that? Okay. Look at this one. What if I had 40 e to the 0.6x power minus 3 equals 237? Okay, so the exponential part of this equation is e to the 0.6x power. I need to move this 3 and I need to move this 40. Which one are you going to move first? The 3. So add 3 to both sides. And I get 40 e to the 0.6x equals 240. Before you can change forms, you have to move that 40. How do I move the 40? Divide by 40. So I get e to the 0.6x power equals 240 divided by 40 is 6. From here, change forms. So log, what's my base? E, log base e of 6 equals my exponent, 0.6x. Log base e, how do you write log base e? Yeah, technically that's just natural log of 6 equals 0.6x. You could divide by 0.6 first and type that all on your calculator, or you can find the natural log of 6 first and then divide by 0.6, whatever you want to do, same thing. So if you find the natural log of 6, it's 1.792 equals 0.6x. Divide by 0.6, and you get 2.987. Oh no, 986. I don't know why I rounded that up. Oh gosh. 2.986 is your answer. Questions about that? Pretty straightforward. Okay, so that is solving exponential equations. Yeah, let me show you one more. So like 98% of the equations you're doing, you can just change forms like this, like solve for the exponential part and then just change forms and you can get your answer. There is one type of problem that you may see on your homework. That's why I'm showing you this. It will not be on your exam, but you may see one on your homework like this problem. And this is a super long one, okay? So if you have 5 to the x minus 2 power equals 4 to the 2x plus 3 power. Okay, so can you turn those both into the same base? No, and we can't really change forms here because if I change forms, which side is my base? You see what I'm saying? So we have to do this a little bit differently. What is the way that we know we can get a variable out of the exponent? Like what's the only way to solve an exponential problem? That one or that one? I can't take the x minus 2 root of each side, right? So instead I have to use the inverse of an exponential function. What's the inverse? A logarithm. So the way we do this problem is we take the log, take the log. Can I take the log of just one side of an equation? No, you have to do it to both sides. So take the log of both sides. And the idea here is you want to be smart about, you can take the log any base of both sides. Would I do log base 7 for this problem? No, that's dumb, right? Which it's dumb to think about it this way, but if this was a 5, I could do log base 5 of both sides and all that would cancel out and I would just get the top. But then again, if it was both a 5, I could just set the exponents equal to each other, right? So I wouldn't really want to take a log like log base 2 or log base 3 or 4 or 5, because if I did log base 4, it fixes this problem over here, but not this one. If I did log base 5, it fixes this problem over here, but not this one. So let's take the common log just so we can put it in the calculator. Okay, so I'm just going to take the common log of both sides. So log of 5 to the x minus 2 power equals log of 4 to the 2x plus 3 power. We can expand these a little bit to be able to solve. Okay, so expanding means I need to take my exponent and write it out front, because that gets the x out of the exponent. So this would be, I'm going to put in parentheses, x minus 2 times log of 5 and 2x plus 3 times log of 4. Okay, so your question at this point is like, where are we going from here, right? We're trying to solve for x. This x minus 2 times log of 5, what is log of 5? A number, right? Couldn't you type it in your calculator and get a number for it? If I can find my calculator. Right, log of 5 is the decimal 0.69897000043. Okay, this log of 4, it's just a number also, log of 4. Oh, I typed it in wrong. Log of 4 is the decimal 0.60205999913. Okay, we are going to leave it as log 5 and log 4 because there's less things to write on your paper than these long decimals. Okay, but it's just a number. So I can just distribute that number to my x and to my 2 and distribute this log 4 to all the stuff in that parentheses because it's just a number. So this means I get, you could write it log 5 times x or x times log 5. It doesn't really matter either way. Usually you put the x out front because the x isn't in the log, and it might look like it's in the log if you put it after. So x times log 5 minus 2 times log 5 equals 2x times log 4 plus 3 times log 4. Again, what's my goal? Trying to solve for x here. Get the x's on one side, get all the other ugly numbers on the other side. So here's an x. I'm going to keep that over here. Here's my other x. Let me move that over. So I'm going to subtract 2x log 4 from both sides. And I'll get x log 5 minus 2x log 4 equals, this 2 log 5 minus 2 log 5, that's just a number. I'm going to move it over here with this other number. So I'm going to add 2 log 5. So on the right-hand side, I just get 3 log 4 plus 2 log 5. Oh, I left this log off. The x log 5. There we go. Okay, it looks like a bunch of gibberish, right? Let's like remind ourselves what this is. X log 5, that's like a decimal times x, right? Minus 2x log 4, that's like a decimal times x, right? This 3 log 4, that's a decimal, plus 2 log 5, that's just decimal. This is just one big decimal over here. So one way I could solve, technically you could get the decimal here and add or subtract the decimals and then divide by that decimal. That's totally one way to do it. I think it's a little bit easier if you pull the x out here. Like it has a greatest common factor of x, right? If you pull the x out, you're left with log 5 minus 2 log 4. Equals 3 log 4 plus 2 log 5. And then how do you solve for x here? It's x times a number equals a number. Divide by that number, even if it is that nasty, long, awful thing. So I'm going to divide both sides by log 5 minus 2 log 4. So I'm left with x equals 3 log 4 plus 2 log 5 divided by log 5 minus 2 log 4. Isn't that just a number? You could type it in your calculator to get the number for that. So you do 3 log 4 plus 2 log 5, get a decimal, divide it by log 5 minus 2 log 4. And you get this decimal. Sorry, the glare is kind of bad. Negative 6.343. Okay, again, technically, if it's helpful, this is really gibberishy and kind of confusing. If it's helpful to change the logs to decimals up here, that's fine. You just can't round that far because your rounding error is going to increase and you'll probably end up really far away from this number towards the end. So if you want to have this as decimals, that's fine. Just know your decimal needs to have like 6 or 7 decimal places that you're working with, okay? For me personally, I would rather write log 5 than a decimal that's 6 or 7 decimal places because it's literally like this is only 4 things I have to write versus 6 or 7 decimal places would be like 8 or 9 things I have to write for each thing. So it's gibberishy, it's ugly, it's not pretty by any means, but it's less writing. And so that's what I prefer. But feel free to use your decimals as long as you keep them super long still and not rounded off. Okay, so we are just going to stop there. We will do logarithmic functions next time. So just make sure you know how to do exponential functions and you can start your homework. You can do half your homework over section 4.4, the exponential equation problems. And I will see y'all on Wednesday.